Hello everyone, myself Divya. Today I am here to discuss about analysis project on Indian Railways. Indian Railways is basically an important body under the ownership of Ministry of Railways, Government of India. It is the fourth largest national railway system in the world by size with a total route length of 78,610 miles as of 31st December 2021. Many of us already know that the first passenger train ran between Porbandar and Thane for a distance of 34 kilometers on 16th April 1853. Beginning from then, railways has become the very important mode of transportation in India. We may not be able to analyze this vast pool of data, but we are here with small set of data to analyze Indian railways. Our project basically consists of these following tasks: data collection, data pre-processing and cleaning, data visualization, data statistics, hypothesis testing. Let's start with data collection. We have imported the data from the following link and then imported JSON, CSV, pandas as PD. We have opened trains.json and trains.csv, which is the basic data for this analysis. Thank you. Handing it over to Yash.
Will be explaining about data pre-processing and cleaning that we have done in our project. So first what we have done is that we have read a file name train.csv using command pd.readcsv. Next, we have capitalized all its columns. Then next, we have dropped some of the columns that are irrelevant for our columns name type.1 coordinates and classes are dropped using command df.drop. Next, we have used command df.add which shows first 5 rows of our data. So here is the output. Here is the remaining part of the output. Now we have used command df.info, which shows us about the columns and number of value points that each column contains. So we can see that almost all columns contain 5,000 value points, and some of them might contain null values, which we do not want in our data. So we have removed those null values using command df.drop. And after executing this command, we have again checked our data using command df.info. And now we can see that we have only 4,593 value points remaining. So it shows that all the null values are now removed. Divya will continue from the next one.
Thank you, Yash. Now we are going with data visualization part. We have many graphs showing us what is basically there in our data. Plot between train number and written train number. So every train has a number, and when it returns back, it has a different number. So we have plotted train number and its written train number as a graph over here visualizing this data. Here we have density curve of distance, which is showing distances on x-axis and density on y-axis. Plot between train and the final destination. So here we are showing train names on y-axis and their final destination, that is where the trains are reaching finally. So the two station code on this x-axis. Here we have plot between train and their station of origin. Before we have plotted with final station, here we are starting with beginning station. So plot between train names on y-axis and from station code on x-axis. Thank you. Handing it over to Utthista.
Thank you, Divya. Here we go with the visualization. This is a plot between train and distance traveled by them. This plot indicates different trains on y-axis and the distance in kilometers on x-axis. Through this, we could infer that there are very few trains that travel less than 2000 kilometers and maximum number of trains travel less than 1000 kilometers. This is a plot between arrival and departure time of a train. This plot is almost in a straight line, which indicates the train which leaves the station early will return back early. Here we go with the plot showing number of trains between the number of the departure station is taken on the x-axis and the destination station is taken on y-axis. This plot infers us to get an idea about the connectivity of any two places through railways. Calculation of total AC coaches in a train. We calculate total number of AC coaches that include first class, second class and third class AC using this code. There are many histograms which helps us analyzing the data clearly. The first histogram shows us about the third class AC. Here, this indicates there are more than 3,000 trains which don't have third class AC, and only 2,500 trains have third class AC. And chair car. There are more than 4,000 trains which don't have chair car, and very less trains, that is less than 500 trains, have chair car facility available. Coming to sleeper, there are more than 2,500 trains, that is approximately 3,000 trains having no sleeper facility, and more than 1,500 trains having sleeper facility. Duration in minutes. It indicates about the number of trains that cross in a particular duration. This histogram of duration in minutes shows number of trains in that particular duration coming to the station. The first histogram indicates about the first class. There are more than 4,000 trains that don't have first class facilities, and very few trains have first class facilities. First class AC. There are more than 4,000 trains which don't have first class AC facility, and less than 5,000 trains have first class AC facility. Second class AC. There are more than 3,000 trains with no second class AC facility, and approximately 15,000 trains having second class AC facility. And the last one is for distance. It indicates the distance traveled by the train. There are, like, most of the trains travel distance less than 500 kilometers. This is what indicated, like more than 2,500 trains travel less than 500 kilometers, and very few trains travel nearly 3,000 kilometers. Handing over to Praveenya.
Thank you, Utthista. Here there is a plot showing the number of total AC coaches in trains, including the first tier, second tier and the third tier. In the plot, the total number of AC coaches are shown on the x-axis and the train names on y-axis. From the plot, if we observe carefully, we can see that the maximum number of trains have 2 AC coaches. Coming to the calculation of time, here there is a code showing us the calculation of time. Total time is equal to duration of hours plus duration of minutes by 60, because 1 hour equal to 60 minutes. And coming to the calculation of velocity, we calculate velocity using distance and time relationship, where time is calculated just above. Here two new columns are being added, the total time and velocity, which we have calculated just in the previous slide. Coming to the data statistics, here we are using the describe function, which helps us to obtain the various measures of central tendency and various measures of dispersion. We have used the describe function for distance, total time and velocity. We will use these calculations in the upcoming parts of our analysis. These measures of central tendency and dispersion are used in plotting the probability distribution curve. Here comes the density curve of velocity.
This is this. The velocity of trains having AC but not sleeper is higher than the mean velocity. For this, null statement is mu equals to 42.38 and alternative statement h1 equals is mu greater than 42.38. Here 42.38 is the mean velocity of all the trains in the data. Distribution curve of these trains having AC but not sleeper, the code is given here and the distribution curve will look like this. Now, we have provided the condition for the having AC coach but not sleeper and describe the velocity column. We got these values. We provide these values to the required variable and x and standard deviation one. Now, with the help of these values, we can get z because n is greater than 30. So z has to be applied in this case. Now the z is 23.37. For this, we have to find z critical. Z critical, since we have taken alpha 0.05, that is 5%, then z critical is 1.65. For this case, H naught is rejected in favor of H1. That is, the velocity of train with AC but not sleeper is greater than the mean velocity. Now, we have done zone-wise analysis also. For better understanding, we have done some reading through by dropping the question mark zone. So for that, the code is here. df.drop is used. And now here are many zones, right? NR, NWR, but we have also only taken 5: NR, NWR, WR, CR, and SR in our analysis. The analysis for NR zone. For this zone, the H naught, that is null statement, is mu equals to 42.38, and alternative statement H1 is mu greater than 42.38. That is, the velocity of the trains in zone NR is greater than the mean velocity. The distribution curve code is given here. The distribution curve will look like this. And by using the function describe function, we can find out count, mean, and standard deviation for this. And now similarly, since the count is greater than 30, we will apply Z test. And the value of Z for this case is 1.46. When we compare this with the Z critical, we find that we cannot reject H naught. Since we do not reject H naught, we cannot comment further on it. Our claim has been disturbed. Now, for the analysis of NWR zone. For NWR zone, null hypothesis is mu equals to 42.38 and alternative hypothesis H1 is mu greater than 42.38. Here also the hypothesis is the trains in NWR zone have velocity greater than the mean velocity. Distribution curve code for this NWR zone. The curve will look like this only. And by using the star function, we get count, mean, standard. Here also count is greater than 30. So we will do Z test. For Z test, value of Z is 3.367. And since the value of Z is 3.367, which is greater than 1.65, which is critical value, we can say that H0 is rejected in favor of H1. So in conclusion of this case, we can say that in this zone, NWR zone, the velocity of train is indeed faster than the mean velocity. Now I hand over the mic to Lakshya.
Thank you, Deepanshu. I am doing hypothesis of zone WR, in which we have assumed null hypothesis is equals to mean velocity is equals to 42.38. This is the command which we have drawn distribution curve of zone WR. This is that we can see that the count of this sample is greater than 430. So we can use Z test. Mean velocity of this sample is equals to 42.38. We can use Z formula to calculate Z value. We can see that Z value is less than critical value, which is 1.65. So we can conclude that we do not reject H0 for zone CR, in which we assume that the null hypothesis is equals to 42.38 and alternative hypothesis is greater than 42.38. This command is help for making distribution curve of sample zone CR. This is describe function which help in for count, mean, standard deviation, or etc. So we can see that the count of this sample is greater than 30. So we can use Z formula, which is, so we can see that Z value is greater than 1.65. So we can conclude that H0 is rejected in the favor of H1. Next hypothesis, which is zone SR, in which we assume that null hypothesis is equals to 4.38 and alternative hypothesis mean velocity greater than 2.38. This is same distribution curve command, in which we can see that the count is greater than 30. So we can use Z test and formula. So Z value is in this case is 6.34, which is greater than 1.65. So we can conclude that the H0 is rejected in the favor of H1. Conclusion: the velocity of train having AC but not sleeper is higher than the mean velocity. The velocity of train zone SR, CR, and NWR is higher than the mean velocity. To analyze zone WR and NR, we don't have enough data, so we cannot conclude that the train velocity is in the zone. Here is the team member's name. Thank you.